To the second part of our QGIS intro, where you learn how to make a heat map and use spatial join to combine two multiple data sets based on their location. What you have here is the task number 2, where you're asked to evaluate a data set in QGIS, do a spatial join, and evaluate the density of a point layer by creating a heat map. Let's dive straight in, and we're going to do that in reverse order. So we start with heat map, then we do a spatial join, and then we are doing a field calculation, or not, because we've done it last week. So you can look it up in last week's tutorial. We go into QGIS. I open a blank one, and I'm going to add all of the layers which we've done last week. So I'm adding all of the layers which we have. I'm adding vector layers, which I downloaded from either the LMS or the Orion portal. And we have on the desktop, we have the City of Melbourne footprints. Add. You see on the left side, now we have the City of Melbourne footprints. Then we add mesh blocks. Add, we see that there's a second layer. Then we add the last part, which is a point layer of public transport stops. Here we go. Let's briefly look at it. What you see here is the first layer is the top layer is a point layer set. The second one are the mesh blocks. And the last one are the building footprints. And when you zoom in, again, we have a little problem. It is not in the right projection. So let's fix that first. We want to have the scene in a projection suitable for Melbourne. And that's here, the GDA 94 MGA zone 55. Let's apply that. Et voila. Suddenly, the buildings look a little bit more rectangular. All right. Let's go back to what we actually want to do. We want to show a density map and of this point layer set. So what we do, we go into properties, and instead of showing it as single symbol, we're going to make it as a heat map. Apply. Let's see what happens. We see automatically we have this dotted, like this blurry kind of construct, which shows where there are high and where there's low densities of bus stops. We can change this now. For example, we can play around with what you can take into account. So you have to think about this, creating a raster data set which is taking into account the number of points within a vicinity. And you can change either the raster accuracy, like making it smaller, or you can also change what is taken into account. So for example here, we look at changing not the resolution, not the raster size, but just what is taken into account. And you can see that it's getting more grainy until it gets to the point of having individual points. And this is, of course, dependent on your size. If you zoom in and you take that same value, you're getting a much more grainy kind of look. Depending on your resolution, depending on your scale, you have to adjust this value to make it suitable for what story you want to tell. I also want to see where this is, so we are adding a little OpenStreetMap map. Drag and drop, you have here on the left side XYZ tiles. Sometimes you have additional ones. I created them myself. You can Google how that's done. Or you can just take the one which is available, the OpenStreetMap, and you change it and put it underneath. And it disappears. Why is that? Because this is a non-see-through layer. So we changed this into something which is a bit more suitable. So either you can just remove the opacity and then you can see through it. Doesn't look really nice, but you can also do something else. You can make it, for example, just darken. And then, what do you say? Let's make it into something which is a bit more green. Let's add that. and we want to have it fully opaque. Apply. And then you see where the very green areas are. If you want to even make it more contrasty, you can change the properties on that and say, I want to have it only in black, or let's make it like this. It's only black and white. You reduce the darkness a little bit. This is me playing around, so please be careful on how you do this. You can also adjust it and have contrasting colors. So you have blue and a yellow, or a green and a red. And you see then the things get a bit iffy. So you really have to think about how you're going to present these elements. There's multiple ways of doing that. I would go just with clear things, so maybe just a black, apply, and maybe a little bit darker, and then also the color which we have, maybe a bit in a brighter color range, something like that. Yeah, that's not really nice. Let's do that. Blues is fine. Okay. The next part is a spatial join. And this is where you have two data sets which you want to combine with each other. Combining layers is very important because you want to have not just the information from one side, but also from another side. So for example, the building footprints we have, let's look at it quickly. Building footprints, let's put them on top of the mesh block and zoom in. The building footprints here in pink, not really nice, but don't worry about it, we can change this, have a certain amount of information, which is quite nice. We have building year, we have number of floors, we have the height of the building, and so on. So for example, we can add these kind of attributes. For example, let's make it into how tall these buildings are, height, classify, and equal count. Then we change this to no outline. Apply. And what you see is, let's zoom out, that the buildings in the CBD are tall, and the ones which are further out are not as tall. They're quite bright, so the brighter they are, the lower they are. What we don't have is the land use of those buildings. So let's switch on these underlying mesh blocks and look at them. So we have the properties, and we want to make a categorized color scale because the category of the land use is a discrete one. And what you can see here is commercial, educational, and so on. So, random colors, apply, OK. Here we go. And you see that there's different colors. They're all a bit in the blues. That's maybe not really nice to show the contrast. Random colors again. Shuffle random colors, apply, OK. So you see that there is a CBD with a certain characteristic, and there is like residential zones which have this kind of minty, and well, you might want to think about what kind of implications that have. Is it just that they are commercial and which makes them tall, or is it something else? So you need to have the information of the land use underneath to then make a conclusion. And that's why you want to have the information of the mesh block connected to the individual buildings. How do we do this? We do a spatial join. There's multiple places you can find that. On the right side, I open something which is called a toolbox. So if you have any problems, you can always go into help and type in things. For example, join. And you find here combined spatial join, which is in different ways, or in managing data management tools. There's always these kind of help which finds the parts. What I want to show you here is this toolbox, because in the toolbox you have all kinds of additional information or additional tools which you can find. We're going into vector general, and below that in join attributes by location, which is exactly the same as data management tool join attributes by location. The input dataset is the underlying mesh block, and the joining dataset is the building footprints. You have the mesh block, and you want to join it to the building footprints. Sometimes these geometries are not precisely in each other. So you have to think about what you want to do. That contains, that means it's 100%. It's exactly the same, so they are really congruent or contiguous on top of each other. They are touching. That's very good. For example, if you have a line, you have a street line, and you want to know what kind of land use it passes through. Overlaps. Is it partially part of it, or is it within? For example, our building footprints can be in multiple mesh blocks. Probably not, but it could be. And if you want to have only the ones which are within one area, for example, I want to have all of the building footprints in Victoria, I don't want to have them in New South Wales or in America, so I'm using within. So there's multiple ways of doing that. I just use intersect. Joining type creates separate features for each location, one-to-many, that's okay. You can also do a one-to-one relationship. You want to have a prefix. So that means when you have additional information from one data set, you want to have it in the next one with an additional information that indicates where you have it from. That's always good. For example, mesh block, I abbreviate as MB and underscore. Then I know that every attribute I'm looking at which has that comes from the mesh block. Create a temporary open output file after running algorithm. Great. We want to actually save it to a file, because if you do it as a temporary layer, it will only create a scratch file. That means it creates it in your RAM, and when you close that file, like your QGIS session, it will delete that. It will not save it to a file. So we create it to a file, and I'm just going to the desktop, and we'll call it footprints MB join. All right, on the desktop. Very good. And let's run this. And it will give me a lot of errors because, and this is now where we get a bit iffy. I have to tell you that sometimes these geometries are not well formed. What does that mean? That means, for example, that a square has the last point not aligned with the first point. And that makes it difficult to calculate, or that there are areas which are outside of your geometry. For example, not every mesh block has a building footprint on top. So what do you do with these features? Now, QGIS has two ways of dealing with this feature. Either it says, stop, hold on, we can't deal with this, we have to first fix the geometries, or it just discards it. And I say, great, I want to have it discarded. Close. And how do you do that discarding? So you go into your QGIS preferences, you get all of this, where you have, like, for example, your projections, and you go down to your processing. You go into your general, and you go into your invalid features filtering. And then on the right side, by default, it is set to stop algorithm execution when a geometry is invalid. We don't want that. We just want it to run through and figuring it out. So we say ignore features with invalid geometries and keep going. So in case you had an error, just adjust this. Right? Okay. And what happened? We have a new geometry. And what is it? It's brilliant. It is actually the wrong way around. So what I did, I made an error. And it's always nice to see that if you're taking the wrong direction, so for example, I did the mesh block first and then the building footprint. We don't want to have that. So we go the other way around, where we first have the mesh block and then, no, the other way around, where we have first the building footprints and then the mesh block. and we're going to save it as a MB join 2. Run. So we have now the building footprints, not only with the information of the buildings themselves, but also of the underlying mesh blocks. So we can make a representation of that by looking at a apply all of master plan. What we have now are the individual building footprints categorized as their land use. This is one of the maps you can create. You can also make new calculations with this. This was it for the second week. Brief recap. It was a bit faster than last time. My apologies if you have not been able to follow. I hope you can slow it down on your end, and otherwise just write it down in the comments, and I hope to see you again next week. Cheers!